ಶುರು ಮಾಡೋದು ಸರ್ ಹಾಗಾದ್ರೆ.
ಎಸ್ ಸರ್ ಶುರು ಮಾಡೋಣ. ವಿಡಿಯೋ ಆನ್ ಮಾಡ್ಬೇಕಾ ಸರ್?
ತೊಂದ್ರೆ ಇಲ್ಲ, ನಿಮ್ ಬೇಕಾದ್ರೆ ಹಾಕೊಳ್ಳಿ ಅಮ್ಮ, ವಿಡಿಯೋ ಆನ್ ಮಾಡ್ಕೊಳ್ಳಿ ಸರ್.
ಎಸ್
1 minute ಸರ್, 1 minute.
ಎಸ್ ಸರ್.
ಸೊ ಎಲ್ಲರಿಗೂ ನಮಸ್ಕಾರಗಳು. ಇಂದಿನ ಉಪನ್ಯಾಸ ಕಾರ್ಯಕ್ರಮದಲ್ಲಿ ಶ್ರೀ ಅಭಿಷೇಕ್ ರವರು ಉಪನ್ಯಾಸ ನೀಡಲಿದ್ದು, ಅವರನ್ನು ಈ ಒಂದು ಕಾರ್ಯಕ್ರಮಕ್ಕೆ ಸ್ವಾಗತಿಸ್ತಾ ಇದ್ದೀನಿ. ವೆಲ್ಕಮ್ ಟು ಯು ಸರ್.
ಥ್ಯಾಂಕ್ ಯು ಸರ್.
ಸೊ ಅದೇ ರೀತಿ ಇಂದಿನ ಉಪನ್ಯಾಸ ಕಾರ್ಯಕ್ರಮಕ್ಕೆ ಹಾಜರಾಗಿರ್ತಕ್ಕಂಥ ಎಲ್ಲ ಉಪನ್ಯಾಸ ವರ್ಗದವರು, ಶಿಕ್ಷಕರಿಂದ, ಅದರಲ್ಲೂ ಕೂಡ ಹಾಜರಾಗಿರ್ತಕ್ಕಂಥ ನನ್ನ ಎಲ್ಲ ವಿದ್ಯಾರ್ಥಿ ಮಿತ್ರರಿಗೂ ಕೂಡ ಸ್ವಾಗತವನ್ನು ಬಯಸುತ್ತಾ, ಮಿಸ್ಟರ್ ಅಭಿಷೇಕ್ ರವರ ಬಗ್ಗೆ ಒಂದು ಸಣ್ಣ ಕಿರುಪರಿಚಯನ ತಮಗೆ ತಿಳಿಸ್ಕೊಡ್ತಾ ಇದ್ದೀನಿ. ಸೊ ಅಭಿಷೇಕ್ ರವರು MSc ಇನ್ ಕೆಮಿಸ್ಟ್ರಿ ಮಾನಸ ಗಂಗೋತ್ರಿಯಲ್ಲಿ ತಮ್ಮ MSc ಪದವಿಯನ್ನ ಪಡೆದಿದ್ದು, ಮತ್ತೆ KSET ಎಕ್ಸಾಮ್ ಕೂಡ ಅವರು ಬರೆದು ತೇರ್ಗಡೆಯಾಗಿದ್ದು, ಅವರು ತಮ್ಮ ಕೆರಿಯರ್ ಇದನ್ನ ರಿಸರ್ಚ್ ಅಂಡ್ ಡೆವಲಪ್ಮೆಂಟ್ ಸೈಂಟಿಸ್ಟ್ ಫಾರ್ ಎ ಫಾರ್ಮಾಕ್ಯೂಟಿಕಲ್ ಇಂಡಸ್ಟ್ರಿ ಅಟ್ Bangalore and also worked for 2 years. As I was more inclined towards teaching, I started teaching and currently working in base PU College, Mysore, and currently pursuing PhD in the field of nanotechnology. Okay, thank you. Over to you, sir. So
thank you sir.
ಮತ್ತೆ ಈಗ ನೀವು PhD ಮಾಡ್ತಾ ಇದ್ದೀರಾ ಸರ್ ಇವಾಗ?
ಎಸ್ ಸರ್, ಕಂಟಿನ್ಯೂ ಮಾಡ್ತಾ ಇದ್ದೀನಿ ಸರ್. ಈಗ 2 years ಆಯ್ತು. ಸೊ ಮಾಡ್ತಾ ಇದ್ದೀನಿ, ವರ್ಕ್ ನಡೀತಾ ಇದೆ ಈ ಕಡೆ ಕಾಲೇಜಲ್ಲಿ.
ಯಾರು ಗೈಡ್
ಮಾಡ್ತಾ ಇದ್ದೀನಿ.
ಗೈಡ್ ಯಾರು ಸರ್?
ಸರ್ HD ರೇವಣ್ಣ ಸಿದ್ದಪ್ಪ ಅಂತ, ಚೇರ್ಮನ್ ಮಾನಸ ಗಂಗೋತ್ರಿ ಕೆಮಿಸ್ಟ್ರಿ ಡಿಪಾರ್ಟ್ಮೆಂಟ್ ಚೇರ್ಮನ್ ಸರ್.
ಐನೋ ಅವ್ರನ್ನು ಕೂಡ ಈ ಒಂದು ಟ್ಯಾಲೆಂಟ್ ಸರ್ಚ್ ಪ್ರೋಗ್ರಾಮ್ಗೆ ಒಂದು ಟಾಕ್ ಕೊಡಿ ಅಂತ ಕೇಳ್ಕೊಂಡ ಸಂದರ್ಭದಲ್ಲಿ ಅವ್ರಿಗೆ ಸಮಯಾವಕಾಶ ಇಲ್ಲ ಅಂತ ಹೇಳಿ.
ಹೌದು, ಅವರು ಚೇರ್ಮನ್ ಆಗಿದ್ದಾರೆ ಈಗ.
ಎಸ್
ಹಾಗೆ ಕೋಗೈಡ್ ಬಂದು ಮಲ್ಲಿಕಾರ್ಜುನ್ ಸ್ವಾಮಿ ಅಂತ JSS ಅಲ್ಲಿ ವರ್ಕ್ ಮಾಡ್ತಿದ್ದಾರೆ. ಅವರಿಬ್ಬರ ಗೈಡೆನ್ಸ್ ಅಲ್ಲಿ ನಾನು PhD ಪರ್ಸ್ಯೂ ಮಾಡ್ತಾ ಇದ್ದೀನಿ ಸರ್.
ಗೊತ್ತು ನಮ್ಮ ಅಕಾಡೆಮಿ ಫೆಲೋವರು ಕೂಡ ಆಗಿದ್ದಾರೆ ರೇವಣ ಸಿದ್ದಪ್ಪ ಅವರು.
ಎಸ್ ಸರ್ ಹೌದು.
ಓಕೆ, ಓವರ್ ಟು ಯು ಸರ್.
ಥ್ಯಾಂಕ್ ಯು ಸರ್.
ಮತ್ತೆ ವಿದ್ಯಾರ್ಥಿಗಳೇ ನೋಡಿ, ಈಗ ನಮ್ಮ ಅಭಿಷೇಕ್ ರವರು ತಾವು ಪಾಠ ಮಾಡದೇ ಇರತಕ್ಕಂಥ ಸಂದರ್ಭದಲ್ಲಿ ಕೆಲವೊಂದು ಕ್ವಶನ್ಸ್ ಗಳನ್ನ ಕೇಳ್ತಾ ಇರ್ತಾರೆ. ನೀವು ಚಾಟ್ ಬಾಕ್ಸ್ ಅಲ್ಲಿ ಮತ್ತೆ ಇದರಲ್ಲಿ ವರ್ಚುಯಲಿ ಅವ್ರ ಜೊತೆ ಇಂಟರಾಕ್ಷನ್ ಆಗಿ ಏನೇ ಈ ಒಂದು ಟಾಪಿಕ್ ಅಲ್ಲಿ ನಿಮಗೆ ಡೌಟ್ಸ್ ಗಳಿದ್ರು ಕೂಡ ಕ್ಲಿಯರ್ ಮಾಡ್ಕೊಂಡು ತಮ್ಮ ಮುಂದಿನ JEE, NEET ಮತ್ತೆ CET ಎಕ್ಸಾಮ್ ಗಳಿಗೆ ಯಾವ ರೀತಿ ಪ್ರಿಪೇರ್ ಆಗ್ಬೋದು ಅನ್ನೋದು ಕೂಡ ನೀವು ಕ್ವಶನ್ಸ್ ರೂಪದಲ್ಲಿ ಕೇಳಿ ತಿಳ್ಕೋಬಹುದು ಅಂತ ಹೇಳಿ ಈ ಒಂದು ಕಾರ್ಯಕ್ರಮಕ್ಕೆ ಅವರಿಗೆ ಪ್ಲಾಟ್ಫಾರ್ಮ್ ಬಿಟ್ಕೊಡ್ತಾ ಇದ್ದೇನೆ. ಓವರ್ ಟು ಯು ಸರ್.
ಥ್ಯಾಂಕ್ ಯು ಸರ್. So good evening students, welcome to this lecture. So ನಾನು Abhishek R. Currently I am working in Base PU College Mysuru and I am associated with Base from past 6 years. 2017 ಇಂದ ಇಲ್ಲಿವರೆಗೂ ಅಲ್ಲೇ ಕೆಲಸ ಮಾಡ್ತಾ ಇದ್ದೀನಿ. ಜೊತೆಗೆ PhD ನೂ ಕೂಡ ಪರ್ಸ್ಯೂ ಮಾಡ್ತಾ ಇದ್ದೀನಿ. ಸೊ ಇದು ನನ್ನ ಸ್ಮಾಲ್ ಇಂಟ್ರೊಡಕ್ಷನ್ ಸರ್ ಕೂಡ ಹೇಳಿದಾಗೆ. ಈಗ we're going to start with a chapter, very important chapter in organic chemistry as far as the second year syllabus is concerned. So ನಿಮ್ಗೆಲ್ಲ ಗೊತ್ತೇ ಇದೆ, ಆರ್ಗ್ಯಾನಿಕ್ ಕೆಮಿಸ್ಟ್ರಿ ಇಸ್ ಒನ್ ಆಫ್ ದ ವೆರಿ ಇಂಪಾರ್ಟೆಂಟ್ ಬ್ರಾಂಚ್ ಆಫ್ ಕೆಮಿಸ್ಟ್ರಿ ಅಂಡ್ ಹಾಗೆ ವೊಲಟೈಲ್ ಕೂಡ ಅಂತ ಹೇಳ್ತೀವಿ. ಆರ್ಗ್ಯಾನಿಕ್ ಕಾಂಪೌಂಡ್ಸ್ ಹೇಗೆ ವೊಲಟೈಲೋ, ಈ ಆರ್ಗ್ಯಾನಿಕ್ ಕೆಮಿಸ್ಟ್ರಿ ಅನ್ನೋ ಬ್ರಾಂಚ್ ಕೂಡ ವೊಲಟೈಲ್ ಅಂತ ಹೇಳ್ತಾರೆ. ಯಾಕೆ ಅಂದ್ರೆ ಇದು ನೆನ್ಪಿಟ್ಕೊಳ್ಳೋದಕ್ಕೆ ಸ್ವಲ್ಪ ಕಷ್ಟ, ಮರೆಯೋದು ತುಂಬಾ ಈಸಿ. ಸೊ ಹಾಗಾಗಿ ನಾನ್ ಹೇಳೋದೇನಂದ್ರೆ, ಯು ನೀಡ್ ಟು ರಿವೈಸ್ ಅಂಡ್ ರಿಕಾಲ್ ಆನ್ ಡೈಲಿ ಬೇಸಿಸ್. ಸೊ ಪ್ರತಿ ಒಂದು ಪಾಯಿಂಟ್ ನಾವ್ ಏನ್ ಹೇಳ್ತೀವಿ ಇಲ್ಲಿ, ಸೊ ಎವ್ರಿ ಪಾಯಿಂಟ್ ಹ್ಯಾಸ್ ಟು ಬಿ ರೆಕಾರ್ಡೆಡ್. ಯು ಶುಡ್ ರೆಕಾರ್ಡ್ ಇಟ್ ಇನ್ ಯೋರ್ ನೋಟ್ಬುಕ್. ಅವತ್ತಿನ ದಿನಾನೇ ಯು ಶುಡ್ ರಿವೈಸ್. Like daily revision is important, weekly revision is important, and after completing the chapter, so chapter wise revision is also very important. So jotege you should also make a key points, key notes kuda important agate, so that whenever you get some time you can just turn back the pages, go through the key notes, and you will be able to easily remember all the contents of a particular topic. Okay, na? So without wasting much of our time, let us begin the topic now. So students, ನಾನು ಪಾಠ ಮಾಡ್ತಾ ಮಾಡ್ತಾ ಒಂದಷ್ಟು ಕ್ವಶನ್ಸ್ ನ ಕೇಳ್ತಾ ಹೋಗ್ತೀನಿ. ಸೊ ಯು ನೀಡ್ ಟು ಇಂಟ್ರಾಕ್ಟ್. ಲೆಟ್ ದ ಕ್ಲಾಸ್ ಬಿ ಮೋರ್ ಇಂಟ್ರಾಕ್ಟಿವ್. ಇದು ವರ್ಚುವಲ್ ಕ್ಲಾಸ್ ಹೌದು, ಹಾಗಂತ ನಾವು ಅಷ್ಟಕ್ಕೆ ಸ್ಟಿಕ್ ಆನ್ ಆಗೋದು ಬೇಡ. ಲೆಟ್ ಅಸ್ ಬಿ ಮೋರ್ ಇಂಟರಾಕ್ಟಿವ್. ಏನೇ ಡೌಟ್ಸ್ ಇದ್ರು ಫೀಲ್ ಫ್ರೀ ಟು ಆಸ್ಕ್ ಮೀ ಥ್ರೂ ಚಾಟ್ ಬಾಕ್ಸ್. ಯು ಕ್ಯಾನ್ ಟೈಪ್ ಯುವರ್ ಮೆಸೇಜ್ ಇನ್ ದ ಚಾಟ್ ಬಾಕ್ಸ್. Is that clear to all of you? Thank you, Shashank. So tell me students, what do you mean by hydrocarbons? Yes, anybody? Hydrocarbons andre ಏನು? I'm waiting for the reply. Hydrocarbons. The name itself is self-explanatory. Hydrocarbons means they are the compounds containing carbon and hydrogen. Very good, Shivraj. So compounds containing hydrogen and carbon are known as hydrocarbons. Basically, this hydrocarbons is classified into two types. We are very much familiar with this. And ನಮಗೆ ನನ್ನ ಫಸ್ಟ್ ಇಯರ್ ಅಲ್ಲಿ ಕೂಡ some basic principles and techniques of organic chemistry ಕೂಡ ಓದಿದ್ದೀವಿ. So hydrocarbons are classified into two types, that is aliphatic hydrocarbons, which is open chain or acyclic. The other one is cyclic hydrocarbons, which are closed cyclic hydrocarbons. So in aliphatic hydrocarbons, depending on the nature of carbon-carbon bond, when I say carbon-carbon bond, carbon-carbon can form three types of bond. One is carbon-carbon single bond, carbon-carbon double bond. The other one is carbon-carbon triple bond. Depending on the type of carbon-carbon bonding. So further, these aliphatic hydrocarbons are divided into two types. Can you name them? ಹೇಳ್ತೀರಾ? How do we classify these aliphatic hydrocarbons into based on the type of carbon-carbon bonding, students? Yes? They are classified into two types, that is saturated hydrocarbons and unsaturated hydrocarbons. So when I say saturated hydrocarbons, they contain carbon-carbon single bond. Saturated hydrocarbons contain carbon-carbon single bond, and that saturated hydrocarbons we call them as alkanes. We call it as alkanes.
Kiran
Can you
Gowda,
just tell me?
Kiran Gowda sent the correct answer, sir.
Yes, Kiran Gowda, very good. It is saturated or unsaturated. So saturated hydrocarbons, we call it as alkanes. So can you tell me what is the general formula of these alkanes? Anybody in the group? General formula of alkanes. Yes, so I'm getting many more replies. Sudeep and Shashank, very good. The general formula of alkanes is CnH2n plus 2. It is CnH2n plus 2. Very good. Likewise, when you say unsaturated hydrocarbons, the bond between carbon-carbon atoms will be a multiple bond. When I say multiple bond, I refer to double bond and triple bond. So there are two types. If the carbon-carbon bond is a double bond, then such hydrocarbons are called as alkenes, that is carbon-carbon double bond. If there is a carbon-carbon triple bond, we call such unsaturated hydrocarbons as alkynes. We call them as alkynes with having carbon-carbon triple bond. So can you just try to tell me what is the formula, general formula of alkenes? Sudeep and Shashank, you are right. It is CnH2n is the general formula of alkenes. Similarly for alkynes, Shivraj, Tejaswini, very good. Yes, it is CnH2n minus 2. That is the general formula of alkynes. So this is with respect to the classification of aliphatic hydrocarbons. Similarly, when you go to the other major important type of hydrocarbon, that is cyclic hydrocarbon, where the atoms are bonded to one another to form a closed structure or ring-like structure. Such hydrocarbons are called as cyclic hydrocarbons. So further, how do we classify these cyclic hydrocarbons, students? Anybody? How do we classify cyclic hydrocarbons? Yes? There are two types. Yes, Shivraj, you were right. Can we name them? Yes? They are classified as alicyclic and aromatic. Alicyclic and aromatic. As and when I say aromatic hydrocarbon, can you think of an example? One best example for aromatic hydrocarbon. Yes? Very good, Shivraj. It is, and Shashank, you are right. It is benzene. The example for aromatic hydrocarbon is benzene having a formula C6H6. Very good. And this is cyclic in structure because all the carbon atoms are connected to one another in a ring-like structure and which is having alternate single bond and double bond. That's the structure of benzene. So now, keeping alkanes and aromatic in mind, let us begin the topic. Alkanes and aromatic hydrocarbons. Okay. So now, when you take alkanes, the general formula of alkane, as we know, it is CnH2n plus 2. Let me clear the board. The formula of alkene is CnH2n plus 2, and they have carbon-carbon single bond. Now what I'm going to do here is I'm going to remove one of the hydrogen from this alkane. I'll be removing one of the hydrogen from alkane and I'm going to replace by another element which is nothing but X. So where X is nothing but halogen. So where this fluorine, chlorine, bromine and iodine. So I'm going to replace one of the hydrogen by an halogen atom. So what do we get, students? What will be the formula? When you replace one of the hydrogen atom of an alkane by an halogen atom, what do we get? Yes, we get alkyl halide or haloalkane, which is having a formula CnH2n plus 1. Because I'm removing one hydrogen, so it will be CnH2n plus 1 and X, which is called as haloalkane, which is known as haloalkane. Or in common system, they are known as alkyl halides. We call them as alkyl halides. Okay, na? Similarly, if you take an aromatic hydrocarbon, that is benzene, with a formula C6H6, from this C6H6, that is benzene, I'm going to replace one of the hydrogen and I'm going to add halogen. So what do we get? Very good. We get C6H5X. C6H5X, which is nothing but called haloarene. Haloarene or aryl halide. Aryl halide. Okay, na? And this alkyl halides at the haloalkanes, we can also represent by another general formula where this CnH2n plus 1, the alkyl group, can be written as R in general and X. So this is the general representation of haloalkanes or alkyl halides. Similarly, haloarenes are aryl halides, that is C6H5 group is written as AR, aryl. AR and halogen is X. Therefore, aryl halides are written as ARX. That is a general representation of haloalkanes and haloarenes. So today we will be discussing in detail about what are these haloalkanes and haloarenes. But have a question. Why is it important to know about these haloalkanes and haloarenes? ಯಾಕೆ ಬೇಕು ಇದ್ರ ಬಗ್ಗೆ ನಮಗೆ ಡಿಸ್ಕಷನ್? What's the use of these substances, haloalkanes and haloarenes? ಹೇಳ್ತೀರಾ? Yes, students? They play a very important role in our day-to-day life. Very important role. Yes, it is used as a medicine. Very good. ಆಮೇಲೆ yes, students. They're used as medicine. Then they are biomolecules. Very good. So now let me give some examples for this. When you take the important compounds, few important compounds of this, halogen derivatives of alkanes and benzene, that is haloalkanes and haloarenes. Let me take the one best example, that is chloramphenicol. Chloramphenicol. Do you know where do we use this chloramphenicol? Anybody? ಎಲ್ಲಿ ಯೂಸ್ ಮಾಡ್ತೀರಾ? It is used as a medicine. Chloramphenicol is used as a medicine. ಎಲ್ಲಿ ಯೂಸ್ ಮಾಡ್ತೀರಾ? These are all the questions which is very important for your competitive exams and also for board exam, like fill in the blanks ಬರಬಹುದು ಇಲ್ಲ it is you like MCQs ಅಲ್ಲಿ ಬರಬಹುದು. It's very important. Very good. It is used as antibiotic. Chloramphenicol is used as antibiotic, which is used to treat typhoid fever. ನಿಮಗೆ ಗೊತ್ತೇ ಇದೆ typhoid fever ಬಗ್ಗೆ. So to treat typhoid fever, we use the chemical substance chloramphenicol. As the name itself suggests, there is an halogen in this chloramphenicol, which is nothing but chlorine. Which is chlorine, an halogen containing substance. Okay. Similarly, our body is known to produce one of the very important hormone. I'm giving you the hint. If that hormone is deficient in the body, we get a disease. No, there is a condition called goiter, where there will be a swelling in the neck region can be seen, and you might have seen ಈ ಕುತ್ತಿಗೆ ಭಾಗದಲ್ಲಿ ತುಂಬಾ ಊದ್ಕೊಳ್ಳುತ್ತೆ, ಅದನ್ನ ನಾವು goiter ಅಂತ ಕರಿತೀವಿ. So which hormone is responsible for that? Can you name the hormone? The deficiency of which will cause goiter? Very good. Very good, Tejaswini. It is thyroxine. Thyroxine. This thyroxine hormone is produced by a gland, that is thyroid gland. Okay, na? And this thyroxine contains iodine in it. It is iodine derivative. It is iodine derivative of tyrosine. Iodine derivative of tyrosine. And the deficiency of this will cause goiter. Deficiency causes goiter. ಹಾಗಾದ್ರೆ how to avoid this goiter? ಹೇಗೆ? ಏನ್ ಮಾಡ್ಬೇಕಾಗಿದ್ರೆ? So we have to intake the salt which is iodized. You might have seen in the advertisements, iodized uppu anta barutte. So that salt will contain iodine content in it, which will help to produce the iodine derivative, that is thyroxine hormone in the body in sufficient amount, which can prevent the goiter. Is that clear? Similarly, we have one more important substance, that is chloroquine. Chloroquine. And this chloroquine is used as a medicine to treat malaria. It is used to treat malaria. Likewise, we have halothane. Halothane. And the structure of halothane is this, students. It is having fluorine, bromine, chlorine. So the three important halogen elements are present in this halothane, that is fluorine, bromine, and chlorine. And this halothane is used as an anesthetic during surgery. It is used as an anesthetic. It acts as an anesthesia. Okay, na? So which contains the three important halogens, fluorine, chlorine, and bromine. So if you look at this, these compounds are made up of, or the derivatives of, halogen compounds. Okay, na? So it is very important to having a knowledge of this haloalkanes and haloarenes. So now let us discuss in detail with respect to one by one. So first I'll be starting with haloalkanes, then we will be moving on to haloarenes. But remember, ನೀವು ಯಾವುದೇ functional group ಅಥವಾ ಯಾವುದೇ organic compound ನ study ಮಾಡಬೇಕಾದ್ರೆ we follow a general trend, a sequence ನ follow ಮಾಡ್ತೀವಿ. So what is the sequence ಅಂದ್ರೆ we start with definition first. Definition of a functional group ಬಗ್ಗೆ ಹೇಳ್ತೀವಿ. ಅದಾದ್ಮೇಲೆ ವಿಲ್ ಬಿ ಡಿಸ್ಕಸಿಂಗ್ ದ ಕ್ಲಾಸಿಫಿಕೇಶನ್. ಈ ತರ ನೀವು ಫ್ಲೋ ಚಾರ್ಟ್ ಮಾಡ್ಕೊಂಡ್ರೆ ನಿಮ್ಗೆ ತುಂಬಾ ಈಸಿ ಆಗುತ್ತೆ ಇನ್ ಮುಂದೆ ಹೇಗೆ ಅದನ್ನ ಸಿಂಪಲ್ ಆಗಿ ಸ್ಟಡಿ ಮಾಡ್ಬೋದು ಅಂತ. ಕ್ಲಾಸಿಫಿಕೇಶನ್ ಅದಾದ್ಮೇಲೆ ವಿಲ್ ಬಿ ಡಿಸ್ಕಸಿಂಗ್ ನಾಮನ್ಕ್ಲೇಚರ್. Then we'll be discussing isomerism shown by these compounds. Then very important, that is preparation, methods of preparation of these compounds. ಅದ್ರ ಬಗ್ಗೆ ಕಲಿತೀವಿ. Then we'll be discussing the physical and chemical properties. Physical and chemical properties. Because once we prepare an organic compound or any compound, it is very important to know what are their properties, both physical properties and chemical properties. ಅದನ್ನ discuss ಮಾಡ್ತೀವಿ. Finally, we'll be discussing the uses of these compounds. Any organic chemistry chapter, if you take the different functional groups, if you take, this is the general sequence that we will be following. So we'll be beginning with definition, then classification, nomenclature, isomerism, methods of preparations of the compound, then physical and chemical properties, and finally the uses. So now let us begin the very first important functional group, that is haloalkanes. Haloalkanes. The name itself is self-explanatory. What do you mean by this haloalkanes? ಹೇಳ್ತೀರಾ? Haloalkanes. Very good, Tejaswini. They are halogen derivatives of alkanes. Halogen derivatives of alkanes. Can you give me an example for this? Example for an alkane. We have written general formula CnH2n plus 2. Allinda, if you remove an hydrogen or more hydrogens and replace by halogen, we get haloalkanes. Yes, Shashank, you are right. Methane, that is CH4. Methane. A simple hydrocarbon, methane. Now, from this methane molecule, I'm going to replace one of the hydrogen by an halogen atom. So what do we get? For example, let me take in particular chlorine. In place of hydrogen, one hydrogen, I'll be replacing one chlorine atom. Yes, very good, Pooja. It is chloromethane. We get CH3Cl, which is chloromethane. Chloromethane. But I have a question for you. Is it only possible to replace one hydrogen, or is it possible to replace all the 4 hydrogen atoms present in the methane molecule? Yes? Yes, you can replace all the hydrogen atoms by using halogen atoms. For example, so Ca3Cl in the, I have Ca3Cl which is having 3 hydrogens. Now I'll replace one more hydrogen by chlorine. So we get CH2Cl2 barutte, correct? From CH2Cl2, I'm going to replace one more hydrogen by chlorine. We get CHCl3. Similarly, in CHCl3, there is one more replaceable hydrogen which can be replaced by an halogen atom like chlorine. We get CCl4. CCl4. So all these are examples of haloalkanes: CH3Cl, CH2Cl2, CHCl3, and CCl4. So these are the compounds which are derived from methane, which is an hydrocarbon. How? By replacing one or more number of hydrogen atoms. ಹಾಗಿದ್ರೆ, how do you define haloalkanes? What are haloalkanes? Can you define? First one, definition. ಹೇಳ್ತೀರಾ? What are haloalkanes? Anybody in the group? Yes? Yes, students. So haloalkanes are the derivatives. Haloalkanes are the derivatives of alkanes in which one or more hydrogen atoms, one or more hydrogen atoms are replaced. One or more hydrogen atoms are replaced by halogen atoms. Halogen atoms. So when I say halogen atoms, it can be either the same halogen atom or it can be different halogen atoms. Okay, now if you look at the examples of the haloalkanes, what I've written here, CH3Cl, CH2Cl2, CHCl3 and CCl4. They're all derived from methane. There is no doubt in that. But how are they different from one another? Yes, students. How are they different? Look at the number of halogen atoms. The first molecule, that is chloromethane, is having one chlorine atom. The second molecule is having two chlorine atoms. The third molecule is having three chlorine atoms. And the fourth molecule, that is CCl4, is having four halogen atoms. So now they are different with respect to the number of halogen atoms present in the molecule. So depending on this category, we are going to classify this haloalkanes into different types. That is based on the number of halogen atoms. So now let us discuss in detail with respect to the classification of haloalkanes. Classification of haloalkanes. So the first classification is based on the number of halogen atoms. Based on the number of halogen atoms. Yes. So if a compound is having only one halogen atom, what do you call them? Any idea? Yes, students? If an haloalkane is having one halogen atom, we call them as monohalogen compounds. Monohalogen compounds. Monohalogen compound. If they are having two halogen atoms, we call them as dihalogen compounds or derivatives. Likewise, if they're having three, we call them as trihalogen compounds. Likewise, if they're having four, they are called as tetra. And if they're having more number of halogen atom, we call them as polyhalogen compounds. Polyhalogen compounds. So the name itself self-explanatory. Monohalogen compounds means they contain one halogen atom. Mono means one. So they contain one halogen atom. So can you give me an example? Example for monohalogen compound. Based on the previous discussion what we had. ಇದಕ್ಕೆ ಮುಂಚೆ ನಾನು ಎಕ್ಸಾಂಪಲ್ ಬರ್ದಿದ್ದೆ which are derived from methane. Very good. It is CH3Cl. CH3Cl is the example for monohalogen compound. Similarly, dihalogen compound based on the previous examples. Yes, CH2Cl2. CH2Cl2. Then for trihalogen compound, we have CHCl3. There are many number of examples, but I'm focusing on one examples. So rest you can go through the book, and if you have any doubts, feel free to ask at any point of the discussion. Then, based on the previous discussions we had, can you just recall a compound which is having polyhalogen? I mean more number of halogen atoms, which we call as polyhalogen compounds. Yes? CCl4, it is tetrahalogen compound, correct? Adikkinta jasti. If it is having more than 4, give me an example. ಸ್ವಲ್ಪ ಹೊತ್ತಿಗೆ ಮುಂಚೆ ಎಕ್ಸಾಂಪಲ್ ಕೂಡ ತಗೊಂಡಿದ್ದೆ, ಸ್ಟ್ರಕ್ಚರ್ ಕೂಡ ಬರ್ದೆ. ಕ್ಯಾನ್ ಯು ಜಸ್ಟ್ recall? It's not benzene. Benzene is made up of only carbon and hydrogen. It is not PCl5. PCl5 is not organic. Yes, Shashank, you are right. C2Cl6. C2Cl6, very good. And one more example, what I had taken in the discussion, halothane. Halothane, which is used as an anesthetic. That is also an example for polyhalogen compound, which is having a formula CF3CClBrH. Athva, let me write the structure. CF3. 3 fluorines are bonded to same carbon. To the other carbon, there is bromine, chlorine, and hydrogen. So this compound is having 5 halogen atoms, which is an example for a polyhalogen compound. Did I make this clear to everybody? Any doubts still here? Students, do you have any doubts still here? Yes, very good. Let's continue now. Now I'll take one more example and tell me how are they different from one another. For example, let me say CH3, CH2, Cl, one example. The other example, CH2 double bond CH, Cl. Okay, na? If you look at the molecule, the formula is different. Of course, yes. This contains 2 carbons. It contains 2 carbons, chlorine atom, but the bond between the carbon-carbon atoms are different. This is carbon-carbon single bond and carbon-carbon double bond. Okay, adanu bitpidana. If you carefully observe the position to which this chlorine atom is bonded, or the carbon to which the chlorine atom is bonded in these 2 examples, how are they different? Helboda? Yes. How the carbon atoms to which the chlorine atom is bonded are different. Isomerism Allah. Isomerism means it should have same molecular formula. Illi molecular formula different irodrinda they are not isomers. Primary carbon. Okay, both of them are primary carbon. It is not different. Eradu primary carbon ide. Yochne ಮಾಡಿ. I'm asking how these 2 carbons. Let me indicate. Let me put a star on these 2 carbons. How these 2 carbons are different. To which the halogen atom, that is chlorine, is bonded. Yes, one carbon is having single bond, the other carbon is having double bond. So can you just relate this carbon-carbon single bond and carbon-carbon double bond with hybridization? Very good, Swati. It is hybridization. They are different with respect to the hybridized state of carbon. Hybridized state of carbon. So based on the hybridized state of carbon to which halogen atom is bonded, we further classify this haloalkanes into different types. So what are those? Let's have a look now. The next classification, the second classification based on the hybridized state carbon to which halogen is bonded.
Pooja Jevar ಕಾಲ್ ಇದೆ ನೋಡಿ ಸರ್.
Yes, sir.
Pooja Jevar.
Yeah, Pooja Jevar, sp3 and sp2. Very good. That is how the 2 carbon atoms are different with respect to hybridization. Awesome, students. So now the second classification is based on the hybridized state of carbon to which halogen is bonded. Now, so as Pooja replied, can you just tell me what is the hybridized state of this carbon? Yes, the carbon that I'm indicating here. Very good. This is sp3 hybridized carbon. And what is the hybridized state of this carbon? The carbon having double bond. Very good, students. It is sp2 hybridized. sp2 hybridized. So depending on the hybridized state of carbon. So now let us classify the haloalkanes. Let me take the first one, that is compounds containing sp3. The first classification, compounds containing sp3 carbon halogen bond. sp3 carbon. Halogen is bonded to sp3 carbon. So let us classify the compounds containing sp3 carbon halogen bond. This is very important for all your competitive exams. Please be careful while listening to this. So based on this, we have different types. The first one is alkyl halide. Alkyl halide. Here, Bodha, what do you mean by this alkyl halide? Yes. So it's very simple. In alkyl halide, the halogen is bonded to sp3 carbon atom. Halogen is bonded to sp3 carbon atom, and that sp3 carbon atom will be of an alkyl group. Very good, Swati. So it is, alkyl halides are the ones wherein the halogen is bonded to sp3 carbon atom. For example, CH3, CH2, Cl. This is one example. CH3, CH, CH3, Cl. Another example. CH3, C, CH3, CH3, and this is Cl. Okay, now, if you carefully observe, look at the carbon to which halogen is bonded. Let me indicate this carbon. This is the carbon to which halogen is bonded. This is the carbon to which halogen is bonded, and this central carbon. Now, if you carefully observe, all these carbons are sp3 hybridized. There is no doubt in that. But how are they different from one another? Yes, Swati, you are right. They are different with respect to the type of carbon. Here, the chlorine atom is bonded to a carbon, and this carbon in turn is bonded to another carbon. So what do you call a carbon which is bonded to one other carbon? Yes? A carbon which is bonded to one other carbon. Very good. It is called as primary carbon. Primary carbon. Now the chlorine is bonded to a carbon which is primary. Therefore, this alkyl halide is known as a primary alkyl halide. It is an example for a primary alkyl halide. Similarly, in the second example, the chlorine atom, which is an halogen, is bonded to sp3 hybridized carbon, but that carbon is now bonded to two other carbons here. If you carefully observe, this carbon is bonded to two other carbon, and what do you call that carbon which is bonded to two other carbon atoms? Yes, Jyoti, you are right. It is secondary carbon. Therefore, such alkyl halides are known as secondary alkyl halides. Secondary alkyl halides. And in the last example, if you see, the chlorine, which is an halogen, is bonded to a carbon, which is sp3, which is an alkyl halide. But here, this carbon is bonded to three other carbons, and that carbon we call it as tertiary carbon. Therefore, such alkyl halides are known as tertiary alkyl halides. Did I make this clear to everybody? Any doubts with respect to the types of alkyl halides? Yes, students, thank you. Can I clear the board and move on to the next category? Well, thank you. Now, let me take one more type of compound in which halogen is bonded to sp3 carbon, but how it will be different from alkyl halide. Let's have a look. Observe. Let me write CH3, CH2 double bond CH, CH2 Cl. This is the example I've taken here. If you observe, the halogen, that is chlorine here, is bonded to a carbon, and this carbon is what hybridized state? Yes, students, the carbon here, the carbon to which halogen is bonded is what hybridized? Very good. It is sp3 hybridized. This is sp3 hybridized. But here, this sp3 carbon is bonded to another carbon, and this carbon is what hybridized? That is carbon having double bond. Very good. It is sp2 hybridized. sp2 hybridized. So what do you call such haloalkanes or compounds wherein an halogen is bonded to a sp3 carbon which is bonded next to a carbon which is sp2 hybridized ಅಥವಾ carbon carbon double bond. Any guesses? Very good. It is known as allylic halide. Allylic halide. Let me take the second one, that is allylic halides, which comes under sp3 carbon halogen bonds. Allylic halides. Allylic halide. So if you observe in allylic halide, the halogen atom is bonded to a sp3 carbon which is bonded to a carbon-carbon double bond. And this carbon, that is sp3 carbon which is bonded to a sp2 carbon of carbon-carbon double bond, we call it as allylic carbon. This carbon, we call it as allylic carbon. anta karitivi. Allylic carbon. So if an halogen is bonded to allylic carbon, it is called as allylic halide. Is that clear? So in allylic halide, the halogen is bonded to sp3 carbon which is next to carbon carbon double bond, which is next to carbon carbon double bond. Did I make this clear? Any doubts? Let's take example for this. CH3 CH double bond CH CH2 Cl. This is an example where the halogen is bonded to a carbon which is sp3 hybridized, which is bonded to a next carbon which is of carbon carbon double bond, that is sp2 hybridized. So therefore this carbon is now called as allylic carbon. Therefore this is an example for allylic halide. Correct? And it may not be in like open chain, it can also be cyclic structures. For example, let me say, this is, observe now. So this is an halogen atom. This halogen atom is bonded to a carbon, this carbon, and that carbon is sp3 hybridized, and that sp3 hybridized carbon is bonded to a carbon carbon double bond which is sp2 hybridized. Therefore this is also an example for allylic halide. Any doubts? Any doubts, students? Yes, let's continue now. So there is one more type of compound which is having, yes sir, isn't that aryl halide? No Shashank, it is not aryl halide. Aryl halide agbeku andre the halogen must be bonded to benzene ring. Direct agi benzene ring carbon ge bond agirbeku. So is this benzene ring what I have written here? Shashank, have I written benzene ring here? Illala. So it is not aryl halide. This is allylic halide. Okay na? Thank you. Now let me move to the third type of haloalkane which is having sp3 carbon halogen bond, that is benzylic halide. Benzylic halide. So what do you mean by this benzylic halide? This is very important. Let me straight away take the example. So this is benzene ring which is having 6 carbons and all the 6 carbons are sp2 hybridized. Now to this I am having a side chain which is CH2. To that there is a chlorine atom. So if you carefully observe, the chlorine atom here in this molecule is bonded to a carbon, and that carbon is sp3 hybridized, and that sp3 carbon is bonded to a carbon of benzene ring. Direct target. So sp3 carbon, if it is directly bonded to a benzene ring, then this carbon we call it as benzylic carbon. Benzylic carbon anta kariyathivi. So if an halogen is bonded to benzylic carbon, we call that compound as benzylic halide. Okay na? Let me take few more examples and tell me how are they different from one another. This is benzene ring CH CH3 Cl. One more example. CCH3, CH3, Cl. Observe ಮಾಡಿ. Are all these examples for benzylic halides? Yes or no? One word answer. Are all these examples for benzylic halides? Yes or no? Yes. They are all the examples for benzylic halides. Can you tell me how are they different? How are they different? Why benzylic halide? Because the halogen is bonded to a benzylic carbon. Therefore, they are benzylic halides. But how are they different? Can you just try guessing it? Very good. The type of carbon is different. You are right, Swati. The type of carbon. When I say the type of carbon, you should observe to how many other carbons a given carbon is being bonded. E carbon, the carbon to which halogen is bonded, ಅದು ಇನ್ನು ಎಷ್ಟು ಕಾರ್ಬನ್ ಜೊತೆ ಬಾಂಡ್ ಆಗಿದೆ ಅದು ಇಂಪಾರ್ಟೆಂಟ್ ಆಗುತ್ತೆ. ಸೊ ಇಲ್ಲಿ in the first example the chlorine is bonded to carbon which is in turn bonded to one other carbon of benzene ring. Therefore this is a primary carbon. Primary carbon. Benzylic halides are called as primary benzylic halides. They are primary benzylic halides. Likewise, so this comes under what category of benzylic halides? Where chlorine is bonded to carbon which is bonded to two other carbons. Yes? Very good. It is secondary benzylic halide. And the third example, the chlorine is bonded to a carbon which is sp3 hybridized, bonded to sp2 carbon of benzene ring. Therefore, it is benzylic, correct? But the carbon, that is benzylic carbon, is bonded to three other carbon. Therefore, it is a tertiary carbon. Therefore, this is an example for tertiary benzylic halide. So therefore, in benzylic halides, the halogen atom will be bonded to an sp3 carbon atom next to benzene ring. Okay, now that's very important. Halogen is bonded to sp3 carbon atom next to benzene ring. Next to benzene ring. So such type of halides are known as benzylic halides. So this is with respect to the first category based on the carbon hybridized state of carbon, that is sp3 carbon halogen bond. Now let me take the second category in which the halogen atom is bonded to sp2 carbon. Okay, now in this case the second one, compounds containing sp2 carbon halogen bond. Compounds containing sp2 carbon halogen bond. ಹೇಳ್ತೀರಾ? So what is this? What type of halide it is? Where halogen is bonded to a sp2 carbon. Very good. It is vinylic halide. The first one, that is vinylic. Vinylic halides. So how do you define vinylic halides? Yes. The halogen atom will be bonded to an sp2 hybridized carbon of carbon-carbon double bond. Halogen is bonded to sp2 carbon atom of carbon-carbon double bond. So such compounds we call it as vinylic halides. The example I've already written there, that is CH2 double bond CHCl, and that is open chain. If I consider a ring-like structure, I can take this as an example where chlorine and halogen is bonded to sp2 carbon of carbon-carbon double bond. This is also an example for vinylic halide. Is this clear? There are many other examples, but I'm taking few. So with respect to this sp2 carbon halogen bond, we have one more type apart from vinylic halide, which is nothing but called aryl halides. Aryl halides or haloarenes. So what do you mean by that? The name itself is self-explanatory. Aryl halides. Aryl halides. ಏನಂಗಂದ್ರೆ? Yes? Aryl halides. What do you mean by that? Correct. They're represented by ARX. Fine. ಏನಂಗಂದ್ರೆ aryl halides. Halogen will be bonded to what? Yes, sp2 carbon. Yes, halogen atom is bonded to aromatic ring, that is sp2 carbon of benzene ring. That is known as aryl halide. Very good, Shashank. Halogen atom bonded to sp2 hybridized carbon of benzene ring. Very good, absolutely right. So if the halogen atom is bonded to an sp2 carbon atom of benzene, they are called as aryl halides. Halogen bonded to sp2 carbon of benzene ring. sp2 carbon of benzene ring. They are known as aryl halides. Example, this is benzene ring. It contains 6 carbons. All the 6 carbons are sp2 hybridized. Now to that sp2 hybridized carbon, we have an halogen which is like bromine. So therefore, the halogen bonded to sp2 carbon of benzene ring is an example for aryl halides. Any doubt still here with respect to classification? Any doubts with respect to classification, students? Okay, so if you have understood this classification, now I'm going to give you some formulas and structures, and you should tell me to what classification of this alkyl halide they belong to. Okay, na? One task over, na? Are you ready? Yes. Take down. I have CH3, CH, CH3, CH2, Cl. Tell me, how are they different? The first one, it's an example for. Very good, Pooja. It is alkyl halide. What type of alkyl halide? Type. Very good. It is primary alkyl halide. This is an example for primary alkyl halide. Next one. The second one. Very good. It is an example for vinylic halide. So andre artha ಮಾಡ್ಕೊಂಡಿದ್ದೀರಾ ಅಂತ ಆಯ್ತು. Good. So now keeping this classification in mind, let us move on to the next one, the very important one, that is nomenclature of haloalkanes. Nomenclature. So, but before nomenclature, I have something to do with dihaloalkanes. When I say dihaloalkanes, what do you mean by that? Dihaloalkanes ಅಥವಾ dihalogen compounds. ಏನಂಗಂದ್ರೆ dihaloalkanes. Yes? Haloalkanes with 2 halogen atoms. Very good. For example, if I say CH3, CH, this is Cl and this is Cl. Okay, na? Next one, CH2, this is Cl, CH2, Cl. Helrappa. Both of these are examples for dihaloalkanes. But the question is, how are they different? How are these two different? In the first example, the 2 halogen atoms are bonded to same carbon. Same carbon. Such compounds are called as, or such halides or dihalides, we call them as geminal dihalides. Geminal dihalides ಅಂತ ಕರಿತೀವಿ. Or in short, sometimes ನಾವು ಇದನ್ನ gem dihalides ಅಂತಾನೂ ಕರಿತೀವಿ. Gem dihalides. Okay na? Similarly, if the halogen atoms are bonded to the neighboring carbon atoms or adjacent carbon atoms, ಅಂದ್ರೆ ಅಕ್ಕಪಕ್ಕ ಇರೋ ಕಾರ್ಬನ್ ಆಟಮ್ಸ್ ಗೆ ಹ್ಯಾಲೋಜನ್ಸ್ ಬಾಂಡ್ ಆಗಿದ್ರೆ such dihalides are called vicinal dihalides. vicinal dihalides or vis dihalides. VIC ಅಂತ represent ಮಾಡ್ತೀವಿ. ಓಕೆನಾ? And also, if the halogen bonded to carbon, if they are identical, that means Lily, if you observe that two halogens are identical, the same identical halogens are bonded to same carbon is like geminal. It's an example for geminal. In specific, if the identical halogen atoms are bonded to the same carbon, then we call them as alkylidin dihalides. Alkylidin. This is competitive question. Alkylidin dihalides anta ಕರಿತೀವಿ. If identical halogen atoms are bonded to the same carbon, it is an example for geminal dihalide, correct? But in specific, we call them as alkylidin. So alkylidin dihalides are the examples for geminal dihalides. Similarly, if the identical halogen atoms are bonded to adjacent carbons, they are vicinal dihalides, yes. But in specific, such dihalides are called alkylin. Alkylin dihalides. Alkylin dihalide. This is very, very important. Do make a note on this, students. Identical halogens bonded to same carbon are called alkylidin, and identical halogen atoms bonded to adjacent carbon atoms are called alkylin. Any doubts? Any doubts? Yes, students. Do you have any doubts? Okay, so now let us move on to the nomenclature, which is very, very, very important as far as your board exam is concerned and all competitive exams are concerned. ತುಂಬಾ ಇಂಪಾರ್ಟೆಂಟ್ ಆಗುತ್ತೆ. ಸೊ ನಾನು ನಿಧಾನಕ್ಕೆ ಮಾಡ್ತೀನಿ ಈ ಚಾಪ್ಟರ್ ನ, ಯಾಕೆಂದ್ರೆ if you know the basics, every basics of like organic chemistry, it will be easy for everybody to understand other organic chemistry chapters. Okay, so now let me discuss nomenclature. ಏನಂಗಂದ್ರೆ nomenclature ಅಂದ್ರೆ ಏನು? What do you mean by nomenclature? Anybody in the group? Very good, Swati. It is naming. How to name an or a compound, that is nomenclature. But when I say naming, there are two types of naming. ಎರಡು ತರ ಇದೆ. Any guesses? What are those? The two types of naming a compound. Yes, one is IUPAC name, the other one is common name. Very good. Common name. This common name we also call it as trivial system. Trivial system of naming anta ಕರಿತೀವಿ. Trivial system. The other one is IUPAC name. IUPAC name. And as we discussed, the general representation of an alkyl halide ಅಥವಾ haloalkane is Rx. It is Rx. Okay na? So Rx andre enilli. So R group represents alkyl group. R represents alkyl. And halogen, it is halide. So in common system, they are named as alkyl halides. But how do you name in IUPAC system? In IUPAC, you need to follow certain rules. It will have a root word, it will have a suffix, it will have a prefix. So root word represents the number of carbon atoms present in the molecule, that is in the parent chain. Okay na? So which is in general given by the root word ALK. ALK. Depending on the type of bonding, that is whether it is carbon-carbon single bond, double bond, triple bond, we have to add a suffix which is ANE if it is carbon-carbon single bond, ENE if it is double bond, and YNE if it is triple bond. So in general, they are the derivatives of alkanes. Okay na? But we have halogen which is a substituent. It is a substituent. If it is a substituent, should I name it as a prefix or a suffix? Very good, Swati. It should be named as prefix. So what is the name for halogen as a prefix? Yes? We have to add the prefix, that is halo. halo. So hence the name, the IUPAC name of these compounds are haloalkanes. Haloalkanes. This is how we name. Okay, na? So keeping this in mind.
Sir, excuse me, you have to take another 5 to 10 minutes, sir.
So can I take if you permit, sir?
Because every session only 1 hour.
Okay, sir.
So next class you will continue on another date, sir.
Okay, sir. Fine, no problem.
ತಗೊಳ್ಳಿ ಬಿಡಿ, ಕಂಟಿನ್ಯೂ, ಲೆಟ್ ದೆಮ್ ಕಂಟಿನ್ಯೂ ಸರ್.
ಅಲ್ಲಲ್ಲ, ಇದು ಸರ್, ಇದು ಸ್ವಲ್ಪ ಮೆಗಾ ಕ್ಲಾಸಸ್ ಇದೆ, ಇದು ಇನ್ನೂ 5-6 ಕ್ಲಾಸಸ್ ಇದೆ.
Okay, okay.
ಸೊ ಅದಕ್ಕೇನೆ ಸರ್ಗೆ ಹೇಳ್ಬಿಟ್ಟು ಇದು ಕಂಟಿನ್ಯೂ ಮಾಡ್ಕೊಂಡು ಹಂಗೆ ಮಾಡಕ್ಕೆ ಇದು ಮಾಡಿದ್ವಿ ಸರ್.
ಫೈನ್ ಫೈನ್. ಸರ್, ಸಿ ವಾಟ್ ಎವರ್ ಕನ್ವೆಂಟ್, ಹೌ ಮಚ್ ಟೈಮ್ ಯು ನೀಡ್ ಸರ್ ಫರ್ದರ್?
ಸರ್ ಹಿಂಗಿಂದು ಅಂದ್ರೆ ಇನ್ನ ಡೀಟೇಲ್ ಆಗಿ ಕಾಂಪಿಟೇಟಿವ್ ಪಾರ್ಟ್ ಗೆ ಮಾಡ್ಬೇಕು ಅಂದ್ರೆ ಇನ್ನ ಸ್ವಲ್ಪ ಜಾಸ್ತಿ ಕ್ಲಾಸಸ್ ಬೇಕಾಗತ್ತೆ. ಬಿಕಾಸ್ ಇದು ತುಂಬಾ ಬಿಗ್ ಚಾಪ್ಟರ್ ಇರೋದ್ರಿಂದ ಅಂಡ್ ವೈಟೇಜ್ ಬೋರ್ಡ್ ಎಕ್ಸಾಮ್ ಗೆ 9 ಮಾರ್ಕ್ಸ್ ಇದೆ, ಜೊತೆಗೆ ಕಾಂಪಿಟೇಟಿವ್ ಎಕ್ಸಾಮ್ಸ್ ಗೆ ತುಂಬಾನೇ ಇಂಪಾರ್ಟೆಂಟ್ ಚಾಪ್ಟರ್. ಹಾಗಾಗಿ ನಾನು ಸ್ವಲ್ಪ ಜಾಸ್ತಿ ಕ್ಲಾಸಸ್ ಸಿಕ್ಕಿದ್ರೆ ಐ ಥಿಂಕ್ ಮಕ್ಕಳಿಗೆ ತುಂಬಾ ಈಸಿಯಾಗಿ ರೀಚ್ ಆಗ್ಬಹುದು ಅಂತ ಅನ್ನಿಸ್ತು. ಸೊ ನೀವ್ ಹೇಗೆ ಹೇಳ್ತೀರೋ ಹಾಗೆ ಮಾಡ್ತೀವಿ, ತೊಂದ್ರೆ
ಇಲ್ಲ. 4 to 5 ಕ್ಲಾಸಸ್ ಬೇಕಂತ ಸರ್ ಅವ್ರಿಗೆ, ಅದಕ್ಕೋಸ್ಕರ.
ಸರ್ ಈಗ ಹೌ ಮಚ್ ಟೈಮ್ ಯು ನೀಡ್ ಸರ್ ಫರ್ದರ್ ಟು ಕಂಪ್ಲೀಟ್ ಇಟ್ ಟುಡೇ?
ಯಾವುದು ಇಡೀ ಚಾಪ್ಟರ್ ನ ಅಥವಾ
ಟುಡೇ ಸೆಷನ್? ಐ ಆಮ್ ಆಸ್ಕಿಂಗ್ ಅಬೌಟ್ ಟುಡೇ ಸೆಷನ್.
ಟುಡೇ ಸೆಷನ್ ನಾಮನ್ಕ್ಲೇಚರ್ ಮುಗಿಸಕ್ಕೆ ನನಗೆ ಇನ್ನೊಂದು 10 ನಿಮಿಷ ಸಿಕ್ಕಿದ್ರೆ ಸಾಕಾಗತ್ತೆ.
ಓಕೆ ಸರ್, ಪ್ಲೀಸ್ ಕ್ಯಾರಿ ಆನ್ ಸರ್.
ಪ್ಲೀಸ್ ಕ್ಯಾರಿ ಆನ್.
ಸ್ಟೂಡೆಂಟ್ ರಿಪ್ಲೈ ಮಾಡಿದ್ದಾರೆ, ಸರ್ ಪ್ಲೀಸ್ ಗಿವ್ ಮೋರ್ ಟೈಮ್ ಫಾರ್ ಆರ್ಗ್ಯಾನಿಕ್ ಕೆಮಿಸ್ಟ್ರಿ. ಬಿಕಾಸ್ ಆರ್ಗ್ಯಾನಿಕ್ ಕೆಮಿಸ್ಟ್ರಿ ಸ್ವಲ್ಪ ಕಷ್ಟಪಡ್ತಾರೆ ಮಕ್ಕಳು. ಸೊ ನಿಧಾನ ಮಾಡ್ಬಿಟ್ರೆ ಅದಕ್ಕೆ ಆಗೋದಿಲ್ಲ.
ವಿಲ್ ಶೆಡ್ಯೂಲ್ ಎಕ್ಸ್ಟೆಂಡೆಡ್ ಟಾಕ್ಸ್ ಆಲ್ಸೋ in continuation with this talk.
Okay,
can continue and finish today's session, sir.
Definitely, yes, sir. So I'll complete nomenclature ಮಾಡಿ wind up ಮಾಡ್ತೀನಿ. So the next 2 we can continue with remaining topics of the same chapter.
Fine, sir. Thank you, sir.
Thank you. ಶಿವರಾಜ್, ಡೋಂಟ್ ವರಿ, ನಾವು ನಿಮ್ಗೆ ಈಸಿ ಆಗಿ ಮಾಡೋ ತರನೇ ಟ್ರೈ ಮಾಡ್ತೀವಿ. ನೀವು ವೀಕ್ ಅನ್ಕೊಳ್ಬೇಡಿ ಆರ್ಗ್ಯಾನಿಕ್ ಕೆಮಿಸ್ಟ್ರಿ. ಅಫ್ ಕೋರ್ಸ್ ಸ್ವಲ್ಪ ಬೇಸಿಕ್ ಸ್ಟ್ರಾಂಗ್ ಆದ್ರೆ ಯು ವಿಲ್ ಫೀಲ್ ಸ್ಟ್ರಾಂಗ್ ಇನ್ ಆರ್ಗ್ಯಾನಿಕ್ ಕೆಮಿಸ್ಟ್ರಿ. ಐ ಆಮ್ ಡ್ಯಾಮ್ ಶೂರ್ ನಿಮ್ಗೆಲ್ಲ ಈಸಿ ಆಗಿ ಅರ್ಥ ಮಾಡ್ಸೋದಕ್ಕೆ ಟ್ರೈ ಮಾಡ್ತಾ ಇದೀವಿ. ಅರ್ಥ ಆಗ್ತಿದ್ಯಾ ಕ್ಲಾಸಸ್, ಆರ್ಗ್ಯಾನಿಕ್ ಕೆಮಿಸ್ಟ್ರಿ ಕ್ಲಾಸಸ್, ಅಥವಾ ಕಷ್ಟ ಆಗ್ತಿದ್ಯಾ? ಎಸ್, ಥ್ಯಾಂಕ್ ಯು. ಸೊ ಲೆಟ್ ಮೀ ಫಿನಿಶ್ ನಾಮನ್ಕ್ಲೇಚರ್ ಟುಡೇ. ಮುಂದಿನ ಕಾನ್ಸೆಪ್ಟ್ ನ ನೆಕ್ಸ್ಟ್ ಕ್ಲಾಸ್ ಕ್ಯಾರಿ ಮಾಡ್ತೀನಿ. ಓಕೆ, ಎಸ್. ಸೊ ನೌ ಲೆಟ್ us discuss the names, the nomenclature, common name as well as IUPAC name for haloalkanes by taking few examples. Are you all ready? Yes, students. Let us begin now by taking examples. Draw 3 columns. 3 column ಹಾಕೊಳ್ಳಿ. First column compound. Second column common name. And third column IUPAC name. So you should know both the names because competitive exams ಅಲ್ಲಿ ನಿಮಗೆ ಯಾವ ತರ ಬೇಕಾದರೂ ಕೇಳಬಹುದು. For any application level questions, they may ask you the question in terms of common name ಅಥವಾ IUPAC name. So ಎರಡು important ಆಗುತ್ತೆ. So you should be thorough with this naming. Okay? Yes, let's begin now. Let me start with the simplest molecule, CH3Br. CH3Br. So as we discussed, in common name we call them as alkyl halides. So can you tell me what is the alkyl group present in this molecule CH3Br? Yes, students. What is the alkyl group? Chloro is substituent. Adu halogen. Alkyl group ನೋಡಬೇಕು ನೀವು. Yes. So CH3 is obtained from methane. I'll make it even very simple. Observe now. CH4, it is methane. Okay, na? Methane in the, if I remove one hydrogen, I get a group which is CH3. Correct? CH3, which is called methyl. ಇದನ್ನ methyl ಅಂತ ಕರಿತೀವಿ. ಹಾಗೆ if I take CH3 single bond CH3, it is ethane, which is an alkane. ಈ alkane ಇಂದ ಅಥವಾ ethane ಇಂದ if you remove one hydrogen, I get a group which is CH3 CH2 ಈ ತರ ಬರುತ್ತೆ, which is called as ethyl. ethyl ಅಂತ ಕರಿತೀವಿ. ಓಕೆನಾ? ಹಾಗೆ in general alkanes na we represent by RH. RH alkanes CnH2n plus 2 RH ಅಂತ ಬರಿತೀವಿ. ERH inda if you remove one hydrogen, I get a group which is R group. Hydrogen illa ali. I have removed hydrogen. We get a group that is R group, which is called as, nodi observe ಮಾಡಿ ಈಗ. Methane, remove one hydrogen, we get methyl. Ethane, remove one hydrogen, we get ethyl. Likewise, propane, remove one hydrogen, we get propyl. ಹಾಗೆ alkane, if we remove one hydrogen, what do we get? Yes. Alkane inda remove one hydrogen. What do we get? Very good. It is alkyl. It is alkyl. ಅದಕ್ಕೆ ನಾನು ಬರ್ದಿದ್ದು general formula RX, haloalkanes. So in common naming, we call them as alkyl halides. Alkyl halide ಅಂತ ಕರಿತೀವಿ. ಓಕೆನಾ? So keeping this in mind, ಹೇಳ್ತೀರಾ ಈಗ CH3Br. What is it? CH3Br. CH3. What is the name? In common system, it is methyl. Br, bromine. So in the compound form, it is bromide. Therefore, it is methyl bromide is the common name. Methyl bromide is common name. So can you tell me the IUPAC name now? In IUPAC system, we call them as haloalkanes. We call them as, we name it as haloalkane. So first you should name halogen part, then you should name the parent chain, carbon chain. So the halogen is bromine, which is named as bromo if it is a substituent as a prefix, bromo. Root word, we have one carbon, therefore meth. And if by default it is single bond, we call it as methane. Therefore the name is bromomethane. Any doubts? Any doubts? Okay, let's go for the next molecule, CH3CH2Cl. ಹೇಳ್ತೀರಾ? CH3CH2Cl. First tell me the common name. CH3CH2. ಎಲ್ಲಿಂದ ಬಂತು ನೋಡ್ಬೇಕು ನೀವು ಅದನ್ನ? It is obtained from ethane. So ethane inda remove one hydrogen, we get ethyl, replaced by chlorine. Therefore the name is ethyl chloride. Very good, Jyoti. Ethyl chloride. So can you tell me the IUPAC name? Very good. It is chloroethane. And remember, you are not supposed to give space between the root words and the prefixes. It should like one word. Chloro admele like space go to ethane baribardu. It should be one word. Chloroethane. No space should be given while writing the IUPAC name. Next, CH3, CH2, CH2, I, CH3, CH, CH3I. Observe ಮಾಡಿ. ಹೇಳ್ತೀರಾ what is the name of this two ಅಂತ? First common name ಹೇಳಿ. First one common name. 1, 2, 3 carbons ಇದೆ, which is obtained from, which is like propane. Propane in the, if you remove one hydrogen, what do we get? Shashank has a doubt. Shouldn't we leave any spaces while writing common name? Illa, common name you can give space. Alkyl halide. I've given space, but IUPAC no space should be given. Very good. It is propyl iodide. Propyl iodide. That is common name. IUPAC name ಹೇಳ್ಬೋದಾ? IUPAC name. Iodopropane. Okay. Iodopropane. Fine. But that is wrong. ಹೇಳ್ತೀನಿ ಯಾಕೆ ಅಂತ. Next one try ಮಾಡಿ. What is the name? What is the name of this compound? Illu observe ಮಾಡಿದ್ರೆ we have 3 carbons, so it should be propyl. But this propyl and this propyl, are they one and the same? No, they are different. Illi all the carbon atoms are in straight chain. Okay na? And if you look at the next molecule here, so it looks like there is CH3 is bonded to second carbon from the end, one end in the other end in the. So this type of structures are called as isostructures. Therefore we call them as isopropyl iodide anta karitivi. Isopropyl. Can you just tell me the IUPAC name of this molecule? IUPAC name. You should select the longest possible chain first. Continuous longest possible chain. ಎಷ್ಟು ಕಾರ್ಬನ್ ಇದೆ? ಈ ಮಾಲಿಕ್ಯೂಲ್ ಅಲ್ಲಿ continuous longest possible chain. 1, 2, 3 carbons. Therefore root word is prop. carbon carbon single bond, therefore propane. ಹಂಗಾದ್ರೆ ಇದು ಅಯೋಡೋಪ್ರೋಪೇನಾ? ಎರಡು ಅಯೋಡೋಪ್ರೋಪೇನ್ ಆಗಕ್ ಸಾಧ್ಯನಾ? ಅಲ್ಲ. ಓಕೆನಾ? They are different. How they are different? Just have a look here. In the first example, in this example, the iodine atom is bonded to a carbon and you should give the numbering now. Number ಕೊಡ್ತಾ ಹೋಗ್ಬೇಕು. And always remember the substituents or the functional group carrying carbon should get the lowest possible number. So when you start numbering the carbon chain, you should have the numbering either from left side or right side. But which is correct? For this example, left to right or right to left? Left to right correcta, right to left correcta, students? It is from right to left, not from left to right. It is from right to left. Yakendre, now this is the substituent. The carbon to which substituent is bonded should get the lowest possible number. Therefore, this carbon will carry number 1, this carbon will carry number 2, this carbon will carry number 3. Next example nodi. The iodine is bonded to a carbon chain which is continuous there 1, 2, 3. And if you observe, either you can write from left to right 1, 2, 3 or from like ಮೇಲಿಂದ ಕೆಳಗೆ ಹೋಗ್ಬೋದು ಇಲ್ಲ ಕೆಳಗಿಂದ ಮೇಲ್ ಬರ್ಬೋದು. ಯಾಕೆ ಅಂದ್ರೆ ಇಟ್ ಇಸ್ ಸಿಮೆಟ್ರಿಕ್. ನೀವು ಯಾವ ಕಡೆ ನಂಬರ್ ಮಾಡ್ರು ಸೇಮ್ ಬರುತ್ತೆ. ಅಬ್ಸರ್ವ್ ಮಾಡಿ 1, 2, 3. iodine is in second position. ಇಲ್ಲಿಂದ ಬರನ್ವಾ 1, 2, 3 same. Iodine is bonded to the same second carbon. Therefore, any direction is it's correct. But now, if you observe these two, the iodine in the first molecule is bonded to first carbon. In the second molecule, it is bonded to second carbon. Therefore, now they are different with respect to position of carbon. Therefore, this molecule is named as 1-iodopropane. It is bonded to first carbon anta. And the second molecule is named as 2-iodopropane. While writing the name, between the numbers and the letter, you should give hyphen. That's the important rule. Is this clear? Is this clear? So textbook ಅಲ್ಲಿ ಇನ್ನೊಂದಷ್ಟು examples ಇದೆ. You can go through that. ಇನ್ನೊಂದೆರಡು example ತಗೊಂಡು ಮುಗಿಸ್ತೀನಿ ಕ್ಲಾಸ್ ನ ಇವತ್ತಿನ ಕ್ಲಾಸ್. Just observe. So take this example. CH3, CH, double bond, CH, Cl. Likewise, CH2, double bond, CH, CH2, Cl. ಹೇಳ್ತೀರಾ? Tell me the IUPAC name. Common name ಬಿಟ್ಬಿಡೋಣ. IUPAC name ಹೇಳಿ. Yes, students. IUPAC name ಹೇಳ್ಬೋದಾ? For these two molecules. How do you number? By the way, how many carbons are there in the chain? 1, 2, 3. 1, 2, 3. ಎರಡರಲ್ಲೂ carbons ಇದಾವೆ. ಅಂದ್ರೆ 3 carbons ಇದೆ. Therefore, root word will be prop. And we have a carbon-carbon double bond. You should add ENE, propene ಆಗತ್ತೆ. Okay na? But we have a substituent that is chlorine. Now, how do you number? To what carbon the chlorine is bonded? The chlorine is bonded to carbon and you should give that the priority barbeku. And also remember, double bond kuda ide. Whenever there is a double bond and halogen atom, you should give the first preference for double bond. ಅದು ಫಸ್ಟ್ ಇಯರ್ IUPAC ರೂಲ್ಸ್ ಅಲ್ಲಿ ನೀವು ಕಲ್ತಿರ್ತೀರಾ. ಇನ್ನೊಂದ್ಸಲ ಒಂದ್ಸತಿ ಓದ್ಕೊಳ್ಳಿ, ರಿವೈಸ್ ಮಾಡ್ಕೊಳ್ಳಿ. ಸೊ when there is a double bond and a halogen atom, priority should be given to multiple bond, that is double bond and triple bond, then halogen. So il double bond irodrinda this carbon will get first priority, then 2, then 3. Next molecule, how do you number? Left to right or right to left? Observe. How do you number, students? Is it from left to right or right to left? ಬೇಗ ಹೇಳ್ಬೇಕು. Very good. It is from left to right. ಯಾಕೆ? ಇಲ್ಲಿ double bond ಇದೆ ಮತ್ತೆ halogen ಇದೆ. And you should give the first priority for double bond. So you should start numbering from left to right. So this is carbon 1, carbon 2, carbon 3. And now the chlorine is bonded to third carbon. Therefore, what is the IUPAC name of the first molecule? Yes, it is 1-chloropropene. It is 1-chloropropene. Because this is propene, chlorine is bonded to first position, 1 chloropropane. Second molecularly, we have chlorine bonded to third carbon. So what is the name? Yes, students, what is the name? Very good. It is 3-chloropropane. ಅಥವಾ 3-chloroprop-1-ene ಅಂತಾನು ಬರೆಯಬಹುದು because double bond is present in first position. Okay na? Any doubts with this nomenclature, students? Do you have any doubts in terms of nomenclature? So there are ತುಂಬಾ examples ಇದೆ ನಿಮ್ಮ books ಅಲ್ಲಿ. You can just go through that. ಎಲ್ಲ ಒಂದ್ಸತಿ ನೀವೇ ಪ್ರಾಕ್ಟೀಸ್ ಮಾಡಿ. Don't look at the answers. So close ಮಾಡಿ and ಆ ಕಾಲಮ್ ನ ಮುಚ್ಚಿ ನೀವೇ ಟ್ರೈ ಮಾಡಿ ನೇಮ್ ಬರೀಲಿಕ್ಕೆ. After writing the name, you just cross verify. ನೀವು ಬರ್ದಿರೋ ನೇಮ್ ಸರಿ ಇದೆಯಾ ಇಲ್ವಾ ಅಂತ. So that will increase your confidence. So ತುಂಬಾನೇ ಇಂಪಾರ್ಟೆಂಟ್ ಆಗುತ್ತೆ. So I'll wind up today's session and always remember ಯಾವುದೇ ಆರ್ಗ್ಯಾನಿಕ್ ಕೆಮಿಸ್ಟ್ರಿ ಪಾಠ ಮಾಡ್ಬೇಕಾದ್ರೆ ನಾನು ಮುಂಚೆ ಹೇಳ್ದಾಗೆ ರಿವಿಷನ್ ತುಂಬಾ ಅಂದ್ರೆ ತುಂಬಾ ಇಂಪಾರ್ಟೆಂಟ್ ಆಗುತ್ತೆ. ಅಂಡ್ ಒಂದು ಇಂಪಾರ್ಟೆಂಟ್ ಫ್ರೇಸ್ ನಾನು ಯಾವಾಗ್ಲೂ ಹೇಳ್ತೀನಿ, ಎ ಡೇ ವಿತೌಟ್ ರಿವಿಷನ್ ಇಸ್ ಅ ಡೇ ವೇಸ್ಟೆಡ್. ಓಕೆನಾ? ಸೊ ಇವತ್ತಿನ ದಿನ ವೇಸ್ಟ್ ಮಾಡ್ಕೊಳ್ಬೇಡಿ, ರಿವೈಸ್ ಮಾಡಿ, ಯೂಸ್ ಮಾಡ್ಕೊಳ್ಳಿ. ಏನಾದ್ರೂ ಡೌಟ್ಸ್ ಇದ್ರೆ ಫೀಲ್ ಫ್ರೀ ಟು ಆಸ್ಕ್ ಎನಿ ಟೈಮ್. ಸೊ ಲೆಟ್ us continue in the next session with respect to the next concepts. Is that clear? Hope you enjoyed the session, students. ಎಲ್ಲರಿಗೂ ಅರ್ಥ ಆಯ್ತಾ? Yes, students. So see you in the next session. Until then, take care. Thank you.
Sir, one more question, the Kiran Gowda.
Ha, ಹೇಳಿ ಸರ್. ಕಿರಣ್ ಗೌಡ.
Explain the ISO and CC
Sir,
compound.
please explain ISO and secondary compounds.
Secondary
Okay.
compounds.
Okay. Observe ಮಾಡಿ ಇಲ್ಲಿ. If I say CH3, CH2, 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 Cl ಅಂತ ಇಟ್ಕೋಣ. ಇಲ್ಲಿ the carbon chain is in straight chain. All the carbon are in straight chain and therefore ಇದನ್ನ ನಾವು normal chain ಅಂತಾನು ಕರಿತೀವಿ, normal chain. And since it is derived from butane, ಇದನ್ನ we call it as N-butyl. Normal chain, N stands for normal chain. So N-butyl chloride ಅಂತ ನೇಮ್ ಮಾಡ್ತೀವಿ. N-butyl chloride, that is common name. IUPAC ನೇಮ್ ತಲೆ ಕೆಡಿಸ್ಕೊಳ್ಳೋದು ಬೇಡ ಈಗ. ಇನ್ನೊಂದು ಸ್ಟ್ರಕ್ಚರ್ ಬರೆಯೋಣ. CH3, CH3, CH2, Cl. Okay na? If you carefully observe, the formula of these is one and the same. Illu kuda 1, 2, 3, 4 carbons ಇದೆ, which is also butyl. But is this butyl and this butyl one and the same? Illa. In this butyl, all the carbon atoms are in straight chain, whereas in the second structure, there is a branch. One branch ಇದೆ. And that branch is to the second carbon from the end. Illinda. Second carbon ಗೆ. ಈ ತರ ಸ್ಟ್ರಕ್ಚರ್ ಬಂದಾಗ we give a prefix iso ಅಂತ. We call it as iso. ಅದಕ್ಕೆ this compound is named as isobutyl chloride ಅಂತ ಕರಿತೀವಿ. Isobutyl chloride. Is that only the structure possible? Illa. Observe ಮಾಡಿ. This methyl, whatever is there in the second carbon here, I can shift to the next position. ಇಲ್ಲಿ shift ಮಾಡ್ಬೋದು. ಅವಾಗ ಹೇಗೆ ಬರುತ್ತೆ? CH3, CH2, CH3, Cl. ಈ ತರ. Okay na? If you carefully observe this structure and this structure, chlorine is bonded to a carbon which is primary carbon. Primary carbon, and this is iso. This is isobutyl. But ಈ structure ಅಲ್ಲಿ the chlorine is bonded to a carbon which is a secondary carbon, because the carbon is bonded to two other carbons. Now secondary carbon ಇದೆ. So chlorine is bonded to secondary carbon, and there are 4 carbons in the molecule. Therefore butyl. But what butyl it is? The chlorine is bonded to a secondary carbon of the butyl group. Hence adana we call it as secondary butyl chloride anta ಕರಿತೀವಿ. Secondary butyl chloride. ಕಿರಣ್, ಅರ್ಥ ಆಯ್ತಾ? Kiran? Yes, Kiran. Thank you. Shashank. Thank you so much. So we'll meet you in the next session with the continuation of the same chapter, haloalkanes, haloarenes. So till then, take care. Thank you. Sir, class wind up ಮಾಡ್ತೀವಿ.
Thank you, sir. Umesh sir. Umesh sir.
Yes, sir. Thank you very much, sir, on behalf of KSTA and on
Thank you
all
so
the
much, sir.
participant students and teaching faculty. Thank you very much. And this is the first time all the students are telling that the one of the best sessions so far in the chemistry subject, sir. Thank you very much for accepting our invitation.
Thank you so much, sir. Anytime ನೀವು ಎಷ್ಟು ಚಾಪ್ಟರ್ ಬೇಕು ಕೇಳಿ ನಾನು ಅಷ್ಟು ಚಾಪ್ಟರ್ ಮಾಡ್ಕೊಡ್ತೀನಿ, ಏನು
Thank you
ತೊಂದರೆ
very
ಇಲ್ಲ.
much, sir. Thank you so
Anytime.
kind of you, sir.
Thank you,
We will
sir.
extend the sessions by confirming the dates from our colleagues, sir. Thank you very much.
Yes, sir. Thank you.
Also, I would like to thank all the audience in the YouTube channel, as well as all the teaching faculty and the students and our technical team and non-technical team of KSTA and Department of Science and Technology, who are the reason behind this successful program. Thank you very much.
Thank you one and all. Thank you KSTA for this opportunity, and thank you students. Thank you so much.
Thank you, sir. This is immense pleasure to once again I thank you, sir.
Thank you so much, sir.
ವಿದ್ಯಾರ್ಥಿಗಳಿಗೆ ಬಾರಿ ಸರಳವಾಗಿ ಕನ್ನಡ ಮತ್ತು ಇಂಗ್ಲಿಷ್ ಎರಡರಲ್ಲೂ ಕೂಡ ಹಲವಾರು ಎಕ್ಸಾಂಪಲ್ ಮುಖಾಂತರ ಈ ಒಂದು ಉಪನ್ಯಾಸ ಕಾರ್ಯಕ್ರಮವನ್ನ ತಿಳಿಸ್ಕೊಟ್ಟಿದ್ದಕ್ಕೆ ನನ್ನ ವೈಯಕ್ತಿಕವಾಗಿ ನಮ್ಮ KST ಪರವಾಗಿ ಧನ್ಯವಾದಗಳು ಸರ್. ಹಾಗೂ
Thank you
ನನ್ನ
so
ಎಲ್ಲ
much, sir.
ವಿದ್ಯಾರ್ಥಿ ಮಿತ್ರರಿಗೂ ಕೂಡ ಧನ್ಯವಾದಗಳನ್ನು ತಿಳಿಸುತ್ತಾ, ನಾಳಿನ ಉಪನ್ಯಾಸ ಕಾರ್ಯಕ್ರಮದಲ್ಲಿ ಬಸವ ಕಿರಣ್ ರವರು ಒಂದು ಅತ್ಯುಪಯುಕ್ತವಾದ ಉಪನ್ಯಾಸ ಕಾರ್ಯಕ್ರಮ ನಡೆಯಲಿದ್ದಾರೆ. ಇದೇ ರೀತಿ ತಾವುಗಳು ಹೆಚ್ಚಿನ ಸಂಖ್ಯೆಯಲ್ಲಿ ಹಾಜರಾಗಿ ಈ ಒಂದು ಉಪನ್ಯಾಸ ಕಾರ್ಯಕ್ರಮಕ್ಕೆ ಹಾಜರಾಗಬೇಕೆಂದು ಮತ್ತೊಮ್ಮೆ ನಮ್ಮ ಕರ್ನಾಟಕ ವಿಜ್ಞಾನ ಮತ್ತು ತಂತ್ರಜ್ಞಾನ ಅಕಾಡೆಮಿ ವತಿಯಿಂದ ತಿಳಿಸುತ್ತಾ ಈ ಒಂದು ಕಾರ್ಯಕ್ರಮವನ್ನು ಮುಗಿಸುತ್ತಿದ್ದೇವೆ. ಥ್ಯಾಂಕ್ ಯು.
Thank you, sir. Thank you.